In this lesson, we're going to be talking about a very simple and intuitive analogy that allows us to better understand what we expect from a neural network and what we're trying to achieve when we employ a neural network. So let's get started with the analogy. Imagine we have a group of people and we want to group them into two classes, class 1 boys, class 2 girls. And of course, these two groups share a lot of common interests. I have considered two of them for you in this slide. As you can see, I've got gaming and shopping. And I think that's one of the easiest way that you can know whether a person is a boy or a girl. Or at least it helps you a lot to classify most of them. So I've got x-axis that shows how much a person loves or hates, I mean, gaming. So 100% that means the person is in love with gaming, or minus 100% means the person hates it. The y-axis shows shopping. Again, 100% shopping and minus 100% interest in shopping. I will probably somewhere around here. I'll put myself somewhere around here because I do enjoy gaming, but I hate shopping. I hate shopping centers. I never go there unless I have to. Anyway, so we can easily classify a bunch of girls and boys using these two features. Again, I want to simplify everything. This is just an analogy. So let's say I've got 5 girls in the first group. These girls, love shopping and they are interested in shopping based on, a value. Let's say this girl 10%, this one 20, 30, all the way to the last one, the orange one up here, which is 100%. And as we go left, which in your case this way, minus 100%, that means they kind of don't like some of them, gaming, some of them really hate. On the other hand, when you go this way, these guys enjoy gaming and at the same time, they basically hate shopping, right? So now my question is, how do you classify these two groups in your mind? All right, of course, in your mind, you first get the picture of, these boys and girls, and then you can easily understand who is who. But what if I replace them with a bunch of circles? What would you say in that case? Well, if you think about it, in your mind, you do not calculate the interest value in gaming or shopping, all right? You never say, okay, this circle has 20% shopping minus 20% gaming. No, you don't say that. On the other hand, you draw a line between these two classes, and that's exactly what we are going to talk about here. So I'm looking for something. You see the black box here? It's not a black box, a red box, but it's a question mark. We are looking for something so that we give these two interest levels as the input, and it gives us one output, either boy or girl. Again, in your mind, you draw an imaginary line between these two classes. Anything on the left-hand side or above the line is a girl. Anything below the line is a boy, or on the right-hand side of the line is a boy. All right? So this line is what you visualize in your mind and what you use, I should say, in your mind to be able to classify them if I replace them with a circle. So now I'm going to classify these two. So the blue color shows the boy group, the pink color shows the girl group. So now this is a line, right? You can find the equation of this line given the gradient and probably 2 points. In that case, I assume that gradient is equal to 1, exactly 45 degrees, and we are sure that it has to intercept the origin, which is where x is equal to 0 and y is equal to 0. So now I'm going to find the equation line that allows us to accurately classify these two classes, boys and girls. So here's the equation for line. Y minus y0 equals to the gradient times x minus x0. And as I said, we know that we're going to intercept the origin and the gradient is equal to 1. So y minus 0 equals to 1 times x minus 0. And if I simplify this, it will give me y equals to 0. And if I move y to the right-hand side and flip everything around, that will be x minus y equals to 0. So here's the equation that I came up with for this line. Now, I can write a condition that allows me to decide whether a given person is a boy or girl based on the value of x and y. Here's the equation. So gender is equal to 1 or boy if x minus y is greater than 0. By the way, I just noticed that I type box instead of boy. We'll have to fix it later on, no problem at all. So gender is equal to 1 or boy if x minus 1 is greater than 0, and gender is equal to 0 or girl if x minus 1 is less than 0. Now with this equation, we can easily classify these two groups, right? And by the way, I think I spelled boy right here. It's embarrassing, I didn't even spell boy right. Anyway, so let's think about one of these people that we already considered to be able to draw that line. So this girl, let's say, she has, x is equal to minus 100 for her, which means she hates gaming, minus 100% not interested in gaming. But on the other hand, she loves shopping. Y is equal to 100. So now if I put that in equation, if I put this in that equation, that will be minus 100 minus 100, which gives us minus 200. It's less than 0. So what's the gender? The gender is definitely a girl. Even without knowing, the picture, if there was no picture and we had only the value, we would be able to confidently say that this is a girl. Let's move on to the next example. In the next example, I'll pick this guy, who is kind of interested in gaming. So 10% is interested in gaming, and minus 5% shopping. So he doesn't like shopping that much, but at the same time, he doesn't hate it. He's a kind of meh, in shopping. If you put these numbers in that equation, what would you get? That would be 10 minus 5, which is equal to 15. Now 15 is greater than 0, so this condition is satisfied, which means the gender is a boy or is a male. And again, if we didn't have the picture of this boy and just x and y, or how much he's interested in gaming and shopping, we would be able to confidently say that it is a boy. And remember, we draw a line, which means I can now calculate or find out the gender of anyone as long as I have the x and y values. See, look at this girl. It's in black. We didn't see her anywhere in this group or even this group, but because we can calculate the values of x and y for her and put that in the equation, we can easily find out the gender. Here's an example. So let's say this guy is one of those, this girl, I should say, this girl is one of those girls who, is interested in gaming a little bit. So gaming interest is 10%. And of course, just like any other girl, she enjoys shopping. So y is equal to 60. Now let's put that in the equation up here. 10 minus 60 gives us minus 50, which means it's negative, and definitely the gender is a girl. Let's move on to the next example. Now I want to show you a boy that we have never seen. Again, it wasn't in a group, it's in black, but we have its value. Let's say this is one of those guys who play a game every single day. So 150% interested in gaming, and shopping is 0. Again, he doesn't care if he goes to shopping centers or not. So if you put that in equation up here, 150 minus 0, 150, it's positive. So what's the gender? The gender is a boy. And guys, that's pretty much everything you need to get started with the neural network. From the very simple neural network to very advanced neural network, deep neural network with thousands and thousands of neurons, which we'll talk about later on, they use these simple technique. They basically draw a line between your one class, two class, or multiple classes to be able to classify them. Don't get me wrong, this is one area that the neural network can be used, but every neural network comes back to this point, to be able to find this equation of lines and classify two groups of people, two groups of students, whatever you can imagine. Because I use numerical values now, right? I said gaming and shopping. You can change it to anything else. You can change it to coordinates of a point. You can change it to color code. You can change it to the number of sales, the amount of money that a company spend on advertisement. Anything that is quantifiable, that you can write in terms of numbers, you can write with numbers, you can quantify it, can be considered as x and y axes here. And of course, once you have those numbers, you can then find the line to separate them. So that is the end of this video. In the next video, we'll be using more mathematical notation to be able to develop this analogy. But remember, everything goes back to this simple analogy. I'm lucky that I realized that this microphone is inside my teacher, not outside. Otherwise, this is what we'll hear. You hear me? This is how my voice looks like when the microphone is inside. And when I move it outside, it's so much better. And of course, this is so much better than everything else. So yeah, I'm lucky. Otherwise, I would have to record this video again. In this lesson, we are going to take one step further and develop a mathematical model for the analogy that I showed you in the last video. And you might be asking, why do we need a mathematical model? Because I already used the equation of line to be able to draw that line, to be able to come up with an equation and decide whether a given person is a boy or girl. Well, that's a good question, and I'm going to start answering that question to justify the existence of this video, a video like this. Remember, we have two groups in that example. Now, I would spread them around. Now, we've got a bunch of boys up here, girls, of course, spread around. As you can see, the line no longer intercepts the origin, and the gradient is also different. It's not equal to 1. It's definitely more than that. So now the question is, how do we now address these things? How do we now change the slope of this line? How do we move it up and down, left or right? So these are the things that motivated me to come up with this idea and develop this model. Don't get me wrong, I'm not the one who proposed these models, but I put everything together in one video to show you how we can take one step further and develop the analogy and make it more mathematical. So let's get started with the mathematical equation in the last video. Remember, it was y minus x greater than 0, 1, y minus x less than 0, 1. And I've got a function here, f, x, and y, or O is equal to f, x, and y equals to that equation. So the first step is to change those input to P1 and P2. I've got f now instead of that question mark. The output is O, the inputs are P1 and P2. So parameter 1 and parameter 2. So I'll be using P1 and P2, W1, W2, all these notations and symbols throughout the course. So make sure to listen carefully and make sure to understand their main purpose. So P1 and P2 are the inputs. What are W1, W2? Those are the weights that you multiply them by y and x. And this time, because I changed them to P1 and P2, I would say the weights for P1 and P2. And remember, I had minus 1 here, so y minus 1 greater than 0. But because I have given it a weight 2, weight 2 can be also minus 1. So you get this equation when weight 1 is equal to 1 and weight 2 is equal to minus 1. So you can now easily, with P1, P2, W1, and W2, create any sort of equation for, instead of the one that I showed you in the last video. And everything is the same. The classes are the same, 1 and 0. 1 means boy, 0 means a girl, and comparison is still the same. So let's put this up here. Now, our model is a lot better, more professional. We've got variables, and it's more general, which means we can now simulate any sort of line. We can now come up with equation of line with changing any of these parameters. So let's take one step further, and instead of 0, I'm saying B. Because if your line doesn't intercept the origin, then you cannot easily say less than 0 or greater than 0. In fact, if it's on 1, for example, you have to say if intercept 1, you have to say if it's greater than 1 or less than 1. And that's what I've done here. So instead of 0, let's use B. And we can then move B to the left-hand side. There we go. So I move this B to the left-hand side. And the next step is to remove the negative sign, because again, B is a variable and it can be negative or positive. So I want a unified model with addition, because I can simulate subtraction when one of these parameters is equal to 1, particularly W1, W2, or B. And there we have it. We have now a simplified model for the equation line that I show you in the last slide. Now, if you have any sort of lines, you can easily model it with these equations. For example, if you want to model y is equal to x2, or x2 minus y plus b equals to 0, you would say p1 instead of x times 2 plus p2 times 1 plus 0, obviously. And later on in one of the videos, I will show you the impact of each of these parameters on the shape of the line. So we have one slide or one lecture on this. So I'm going to wrap this up. Make sure to memorize this equation, because for every single neural network that we'll be using and we'll be implementing, that's the first step. The first step is to implement and consider this equation. In the last video, we came up with the idea of having a unified mathematical model to be able to represent any sort of line in the 2D space. And here's the equation. Now, I'm going to use bits and pieces of this equation to develop a conceptual model of a neuron, and I'm going to talk about it in a moment. So let's start with highlighting different components of this equation with different colors. So I'll be using the same color in my model too. So the output is yellow, the inputs are yellow too. The function is red or dark pink. It depends on the LCD that you have, but to me it looks like a very dark pink. And I've got the addition here. Everything is else black. The addition is in green. Now, here we go. So let's start with 2 circles for the input. And those circles are connected to a summation unit, a big circle that will add them. So without those weights, this circle just adds P1 and P2. But remember, in our model, we have to also multiply them by a bunch of weights, and in this case, 2 weights. W1 and W2. So here's how we have to read this diagram, or this model, I should say. P1 times W1 plus P2 times W2. It looks better and easier to discuss the structure of, for example, equation, right? It's so much easier because then you can add more circles to show that there are more parameters. You can add more circles in the output, which is the next step, of course. You can have a bias as well, or B in this case. So I'm going to add also B because remember, we multiply P1, W1, P2, W2, and we have to also add B, which we'll call it bias at some point, but for now, I just say B. So this is going to give us an output, but remember, this calculation or this expression goes through a filter, which is a function, because we either get 0 or 1. So the output includes only 2 values. But if you don't have that circle, which is again dark pink, the answer would have been a value, probably fractional values, which we don't know. It depends on P1 and P2, W1, W2, and even B. But we expect this mathematical model to to give us two outputs, and there we have it. This is now a mathematical model. It's not a mathematical model, it's a conceptual model. So we have the mathematical model up here, and its equivalent conceptual model down here. Now, let's see how we can use both of the models to be able to go through the example in the first video on the analogy in this series. So remember, W1 is equal to 1, W2 is equal to minus 1. That was x minus y less than 0 or greater than 0. There we have it. P1, P2, these are unknowns. Depending on the person, it might be 0, 10, 10, 20, whatever. You know why? Because these are interest in gaming and shopping or anything else that you can imagine. Then B is equal to 0 because we're going to compare it against 0. And the output is either 1 or 0, right? Now we can use any of these models. I'll be using the conceptual model here to be able to find the gender of this person. So we don't know if it's a girl or boy. But we know that x is equal, P1 I should say, don't use x, I'm not going to use x anymore. P1 is equal to 10, P2 is equal to 2. There we have it. Let's give P1 10, P2 2. We calculate the output, and the output gives us 1, which means it's a boy, which makes sense. Remember that equation? X minus y, there we have it. We have now P1 minus P2. So the gender is a boy. What about this example? Now I have 2 as the input, as the first input of P1, and 10 as the second input of P2. Here we go. 2 times 1 plus 10 times minus 1 gives us minus 8. Minus 8 is less than 0. Everything is done internally in this model. That gives us 0. So what's the gender? The gender is a girl, right? And guys, again, this is the most fundamental model in the field of neural networks. What you've seen just now right in front of your eye was the building block to pretty much all neural networks in the world. Now, my question is, was it easy? Was it very difficult to understand? I don't think so, right? And that's why I started this course with this analogy and this series of videos, because I want to make sure that you know how easy some of these neural networks are and how easy they are when it comes to these simple models. And the more you learn about neural networks, the more you get the feeling that they are not that smart, or they are not that intelligent, and they are not very difficult as people assume. And so that was my main objective of designing this series of video. So now you've got the basics, you've got a basic understanding of neural networks, right? So now it's always whenever I talk about a neural network, think about those lines, classes, and stuff like that. And in the next series of videos, we'll see how we can, add multiple of these models together, how we can connect them to make a network of neurons, and what even a neuron is. See, I haven't talked about neuron yet. I haven't talked about perceptron. I haven't talked about any other technical details because I wanted to make sure that you know how easy the basics and the foundation of neural networks are. So without further ado, let's watch the other videos and dive into these fascinating mathematical and conceptual models. So that was the first section of the course, guys. Go and grab a coffee or tea just like me. Enjoy before you start the next section. Thanks for watching.